Hello everyone, my name is Ashish from Group A10. Today I'll be giving a presentation on our mini project which is based on Internet of Things, and the title of the project is Navigation Device for the Blind using IoT. According to World Health Organization, 39 million people are estimated to be blind and they require more hands to help them to handle tasks. They deal with a lot of challenges on a regular basis. Thus, the project goal is to provide a low cost and more effective method of assisting those who are blind or visually impaired. This way, the user can avoid collisions and injuries and navigate with more confidence and accuracy. The device is fully automated and does not require any manual input from the user. It is a simple yet effective solution that can enhance the quality of life of blind people. Existing systems for visually impaired people. Using a variety of resources and methods, a large number of individuals with severe vision impairments are able to travel on their own. Some of these are mobility enhancing devices like white cane with a red stripe, which is a universal sign of blindness. To increase the user range of touch sensitivity, a long cane is employed. To find the obstructions, it is typically swung in a low sweeping motion across the intended direction of movement. A tiny percentage of people also use guiding dogs to help with their mobility. These canines are skilled and navigating through a variety of obstacles and indicating when it's time to move up or down a step. Some blind people can locate silent items using only their mouths to click and listening for the echoes that return. It has been demonstrated that professionals in blind echolocation process the echoes using what is often the visual part of their brain. Other technologies include electronic orientation aids or EOAs. EOAs provide the blind with situational awareness and guidance in unknown environments. They use technologies such as GPS and Bluetooth to assist users in navigating their surroundings. Tactile maps and graphics. Tactile maps and graphics are used for the raised surfaces and textures to represent spatial information. These can include braille maps, 3D printed models, and tactile diagrams. Assistive platforms for spatial cognition. These platforms integrate spatial awareness and mobility theories. They aim to provide a novel orientation and mobility assistive device for the blind. Proposed system. The goal of the navigation device for the blind using IoT project is to create a product that will be extremely helpful to the people who are blind or visually impaired. Navigation device for the blind project is an invention that makes easier for people to move. It consists of a wearable device consisting Arduino Uno microcontroller paired with ultrasonic sensor which emits ultrasonic waves to detect the obstacle in front of it and give a feedback in the form of auditory or a tactile feedback with the help of buzzer and vibration motor respectively. The device is fully automated and does not require any manual input from the user. It is a simple yet effective solution that can enhance the quality of blind people. UML diagrams. UML stands for Unified Modeling Language. It is a simple way of explaining to non-programmers the key specifications, functionalities, and operation practices of the system. Some of the diagrams include a sequence diagram. A sequence diagram is used to illustrate the dynamic behavior of a system by showing the interactions among various components. In our case, the components are the blind person, the device, and the obstacle. When the user equips the device and turns it on, the device compiles the Arduino program, and the Arduino program enables the ultrasonic sensor and it scans for the obstacle in front of it. And when the obstacle is detected, the device rings a buzzer and vibration through buzzer and vibration motors, and the feedback is given back to the blind person. The next diagram is the activity diagram. Activity diagrams are used to show how control moves through a system. In our case, the black circle represents the starting of the system. When the power is turned on to the system, it initializes the program and starts the obstacle detection. The measure distance is taken into account and checked for the threshold value. If the distance is within the threshold value, the trigger is set off, and if it's not within the threshold value, it continues the loop of measuring the distance. The next diagram we're going to talk about is the use case diagram. Use case diagrams are used to show how a system or a component of a system operates. In our case, the main system is the wearable device, and the two other actors are the user and the obstacle. When the user turns on the system, the Arduino Uno is turned on, and the obstacle detection for ultrasonic sensor scans for the obstacle ahead of it. And when it detects an obstacle within the threshold value, the buzzer and vibration motor are set off and gives a feedback to the user. Class diagram. The class diagram is the most used type of UML diagram. It consists of various classes that represents a system structure. In our case, the the various classes are the power supply, main system, the Arduino Uno microcontroller, ultrasonic sensor, alert system, and the obstacles. Deployment diagram. Deployment diagram is another form of UML diagram. It represents the hardware components and the software components of a device. In our case, the hardware is the main system, and the software side are the Arduino program and the data from the ultrasonic sensor. The system architecture. The system architecture of our device consists of two parts: setup and loop function. When the user turns on the device, the microcontroller enables the ultrasonic sensor and sends a trigger. Then it measures the duration and it is sent to the loop part, and the distance is calculated from the duration of the ultrasonic wave to bounce back. If the calculated distance is within the threshold value, if the condition is true, buzzer is set off and it gives an alert to the user. And if the it is not under the threshold value, no sound will be produced. This is how our build device will look like. The hardware requirements for our device are Arduino Uno, which is a microcontroller based on Atmega, ultrasonic sensor which emits ultrasonic waves, scan the obstacle in ahead of it. Buzzer gives an auditory feedback. Jumper wires are used to connect various other components of our device. 9-volt battery provides the power supply to the Arduino Uno, and the vibration motor gives the tactile feedback. The software which we'll be using is Arduino IDE 2.3.2. The source code will look something like this. It consists of global declaration where the pins are initialized, and the setup function where the pin modes are given. The trick pin refers to the vibration motor which is set as output, and the buzzer is also set as output. The echo pin is the ultrasonic sensor and it gives the input to the Arduino. The loop is the main part of our program. This part is for the feedback that the device is turned on to the user by setting it low, high, low, meaning turning off, on, and off. The duration will be stored in the duration variable, and the distance is calculated by the formula. This is the threshold value which we have given as 50 units, and when and if the calculated distance is within the threshold value, the buzzer is turned on, then it is turned off after a second. A delay is given after the buzzer is set off. This is to print the out distance in the serial monitor. The output in the serial monitor will look something like this. It is used for testing and accuracy purposes. Now for the implementation part.
This is the device for the project navigation for the blind using IoT. So we have used an Arduino Uno, ultrasonic sensor, buzzer, vibrator, and we have sourced the power with a battery, 9-volt battery. So working mechanism involves whenever there is an obstacle in behind the uh, ultrasonic sensor, the Arduino gets to know that there is an obstacle, and it tells the buzzer to ring. So we have embedded the code inside the Arduino Uno. So whenever the battery is on and whenever there is an obstacle in front of the ultrasonic sensor, the buzzer and the vibrator rings. So the working involves whenever there is an obstacle in front of the ultrasonic sensor, the buzzer and the vibrator rings. So as you can see in this video, we are working. So this is it from the implementation part.
Coming to the conclusion, to support the blind, a less complicated, portable, economically efficient, user friendly, and an effective system with many more incredible features and benefits is suggested. Determining the distance between the object and the sensor will be an easy and simple task for the system. It can send signals to blind individual and identify items in all the directions. The visually impaired individual will be able to travel around and go about their daily life without the assistance of other people. That was our project. Thank you.